All right, we're going to start going over problems 11 through 15 of the 2018 January exam in geometry. Okay, so let's get to it. There'll be some notes for you to write down. I'll let you know what those notes are when we get to them. All right? Let's read the question. It says rectangle A prime, B prime, C prime, D prime is the image of rectangle ABCD after a dilation centered at point A by a scale factor of 2/3. Which statement is correct? So I always want to tell my class, and just tell anyone taking this test, is to identify the key words when you look at a question. All right, so if I'm looking here, I see the fact it's a rectangle. That's the first thing I notice. It's a rectangle. Now, maybe that'll be important, maybe it won't, but it's a rectangle. So be thinking in your mind, what does a rectangle look like? What are its properties? All right, next thing I would say is image. Okay, remember when you do any type of transformation, you have a pre-image, which is your original, and an image, which is the new. All right? Let's see. Then it says A, B, C, D. Okay, so let's see, what other keywords here? Scale factor. And centered at A. So we have it centered at point A. Remember when you do a dilation, you have a center and you have a scale factor all the time. All right, our scale factor is 2/3. Now the fact it's 2/3, it should automatically, if you had been paying attention in class or if you just remember this fact, is that 2/3 is below 1. So that should tell you something about the image, okay? That should tell you something about the image. Then they have 4 options here for what's true or what statement is correct. That means 3 of them are not correct, 1 of them is. On these tests, they like to throw in a question that says the opposite, that says which is not correct, which means 3 of them are correct. But here they say which statement is correct, So that means 1 of these is correct. All right, so let's write down these notes here. All right, first of all, when a dilation is done to a figure with a scale factor between 0 and 1, so I'm going to go ahead, between 0 and 1, all right, the image will be a reduction, which is smaller than the original. So when you see that scale factor, you automatically should have said to yourself, okay, I know my new figure is going to be smaller. All right, now, to find the perimeter of the new figure, just multiply the perimeter of the pre-image. Just multiply the perimeter of the pre-image by the scale factor. And this does not work for area. We're going to do a little example of showing why. Why does this not work for area? And it's always good to actually, for me, to actually draw an actual example. And that just helps me out. All right, so I'm going to draw a rectangle. So I'm going to draw an original here, or a pre-image. Let me call it a pre-image, because that would be my original, the pre-image. So let's just say I have a rectangle here, and I have dimensions of 9 by 12, all right? And then I want to dilate this by scale factor of 2/3. And it really doesn't matter in this case what the center is. Sometimes it does, in this case it doesn't. So if I wanted to do an image with a scale factor of 2/3, I would have to multiply each side by that number. So 9 times 2/3 is going to equal 18 over 3, which is equal to 6. So I have a new figure over here, new rectangles. Now that would be 6. And then 12, so then I do 12 times 2/3, which equals 24 over 3, which is equal to 8. So this would be 8. All right, so now let's look at something here. So my area, so I want you to write this down. Area is equal to length times width. Perimeter is equal to side plus side plus side plus side, okay? In a rectangle at least. It's just add up the 4 sides. That's all it is, all right? So the area of this, the area of my original, my pre-image, A would equal 9 times 12, which is 108. 108. My perimeter would equal 9 plus 12 plus 12 plus 9 So that's 24 plus 18, which is 42. All right, now let's go over to my image. My image in this case would be the area would equal 6 times 8, which is 48. My perimeter would equal, let's see, 8 plus 6 plus 8 plus 6, which is equal to 28. All right, now, which one of those? Now let's look at our answers, okay? Maybe you've already seen what the answer is, but let's look at our answers. All right, I'm going to erase this now. It says rectangle ABCD has a perimeter that is 2/3 of the perimeter of the original ABCD. All right, so let's look. Is that going to be true? Well, let's take our image or our new. We've called this new and this old. We've done that before. So I'm going to take my new perimeter, which is 28, and I'm going to divide it by the old perimeter, which is 42. Now, if you reduce that, you'll see that you end up with 2/3, right? Because you divide both these by 14, divide by 14, you end up with 2/3. So that perimeter is 2/3. Now, if we did the same thing with the area, so if I did 48 over 108, you don't get 2/3. You get something else. If I wanted to reduce that, I'm not even sure what you'd get. Let's see, plug in 2, or not plug in 2, but divide by 2, you'd have 24 over, what's that, 54, and then you can keep going with 2, that'd be 12 over 27, I believe, that looks right. And then if you keep going with 2, you get 6, well, you can't go with 2 anymore. You can go with 3, so that'd be 4 over 9. Yeah, that's it, so 4/9. That's not the same as 2/3. So really the point is that answer A is going to be it, because look at our other options. It says rectangle ABCD has a perimeter that has 3 halves, or 3 over 2. No, that would mean that the new one is bigger. Then it says that rectangle A prime, B prime, C prime has an area that is 2/3 the area. Well, we just showed that that's not true. And does the area, is it 3 halves? No. Okay, so our answer is number 1. All right, so go ahead and write that down. Okay, looking at number 12, it's something we have not done in class. If you're watching this from my class, at this point in the year, we have not done this yet. If you're someone else watching it, maybe you have. All right, but it says the equation of a circle is this right here. So, all right, so the equation of a circle is the following here. So they give you the equation of a circle. All right. What are the coordinates of the center and the length of the radius? Okay, in order to do this, you're going to have to put the equation in standard form. All right, you're going to have to put it in standard form. So I'm going to give you some notes that I want you to write down here. All right, and go ahead and do this. All right, so the first thing you're going to have to do is get the equation in standard form by completing the square. And you're going to have to do it twice in this case. You're going to have to complete the square twice. Once you get the equation in standard form, you can identify the center. You can identify the center by looking in the parentheses, and you'll see what I mean. You'll see what I mean when we do it. And then you take the opposite. So whatever's in the parentheses, if you have like 4 comma, or x minus 2, you're actually going to have a plus 2 as the center, okay? And so on, but we'll see that. And then you get the radius by taking the square root of the number that's by itself on the right-hand side of the equal sign. All right, also, this is the standard form of the equation, or standard form equation of a circle, x minus a squared, parentheses squared, plus parentheses y minus b squared, all right, is equal to r squared. So the a and the b are going to be how you find your center, and then the r, you're going to take the square root, that'll be your radius. All right, so let's go ahead and do this. All right. Okay, so what you're going to need to do, I'm going to group my x's and my y's together. All right. If you've completed the square, you've seen this process before, so I'm not going to go too in depth in how to do that, but I'm going to do it here. All right, so what I'm going to do is I'm going to have x squared, and I'm going to have minus 6x. I'm going to leave a little space right here. I'm going to leave a little space right there. And then I'm going to put my y squared, so plus y squared, and then plus 2y. I'm going to have to move some stuff here. I'm going to have to move this over and get rid of this. Okay. All right. I'm going to have a plus, and I'm going to have a little space there for a number I'm going to put in. And then I'm going to equal, you have the 6, so you still have the 6, but I'm going to have whatever I put in here and here, I'm going to have to put over here also. I'm going to have to put this over here. Actually, I'm going to move these notes way down so I can have some room here. All right. All right. So okay, you might be asking, how do I figure out what number to put in right here? Okay. So what you want to do, you're going to take half of the number right here. So that negative 6, you're going to take half of that and square it. All right? Half of that and square it. So half of negative 6 divided by 2 is negative 3. And when you square that, you get 9. So that's going to be, it's going to be plus 9. All right? Do the same thing over here. You take half of 2. All right? So 2 divided by 2 is 1. And then you square 1, you just get 1. Right? So I have that now. Now, the good thing about what I've formed here, all right, is I can write that in a specific way. So how can I write that? Well, let's go ahead. What you've created is a perfect square trinomial. So what I'm going to actually have now is x minus 3 squared. All right? So this whole thing I circled in blue can be written as x minus 3 squared. All right? Now, over here, same thing, you're going to end up with y plus 1 squared. Now, one thing I just forgot to do, all right, what am I going to be putting over here? Well, I told you, whatever number you put in on the left-hand side of the equal sign, you have to do the same thing on the right. So I'm going to have a plus 9 and a plus 1, all right? So now I have equals 6 plus 9 plus 1, which is 16. All right, now we're in the right form. All right, so we have x minus 3 squared plus y plus 1 squared equals 16. So now the radius is just going to be taking the square root of this number. That'll be your radius. You notice in the answers they give you 4 and 16, because a lot of students, if they get this far, they see 16 and they forget they have to take the square root. But the radius is actually going to be 4. All right, so we can eliminate 3 and 4 right here. Then you have to look in your parentheses. You see how you have a negative 3 and a positive 1? You have to take the opposite of those numbers. So since you have a negative 3 and a positive 1, your center is actually going to be positive 3, negative 1. So your answer actually has to be that. Okay, so number 2 is your answer there. All right? We'll move on to number 13. All right, let's look at number 13. It says in the diagram of triangle ABCD below, DE, so I'm gonna outline DE is parallel to AB. All right, CD is equal to 15, AD is equal to 9, and AB is equal to 40. So they label all the sides for you. Now, I always tell students, when you read these questions, why are they giving you the information they're giving you? Okay, why are they telling you that DE is parallel to AB? There has to be a reason for that. I'm going to mark this, okay? So those two sides are parallel, all right? Now, what I told students, okay, is when you have a triangle within another triangle. So you can see here, we actually have two different triangles. So I have a triangle here, I have a triangle here, and I have another triangle here. All right, I would always write them separately. It's going to make it so much easier on you. All right, here, now, I have some notes I want you to write down, so go ahead and write these down. So go ahead and pause the video, because I'm not going to keep them up for long, or I'm going to move on pretty quick here. So go ahead and pause. Okay, so hopefully you drew the triangle separately. Because of the fact we have parallel lines, that's going to mean that these angles here are the same. Okay, and so we can say that those triangles are similar by angle. And so that'll allow us to set up a proportion. So let's go ahead, I'm going to move this out. And I'm going to move this out here, this red one. All right, so now I have two triangles here. All right, and I'm going to label it. So I have this side would be 15. And then this side, now the one students get confused on is this entire side here. So this side over here, this blue one, is going to be 24. And then we have 40. And what we're looking for is DE, which is X. All right? So now we can just set up the number of proportions you can set up, but I did 15 over X is equal to 24 over 40. So remember, then you have to cross multiply. So we end up with 24X is equal to 15 times 40 is 600. Then you divide by 24, you divide by 24, and you end up with X is equal to 25. Pretty straightforward. Once you draw the triangle separately, it becomes much easier. If you don't do that, good chance you're going to make a mistake. All right? Good chance you're going to make a mistake. All right? Okay, we're going to move on. All right, so looking at problem number 14, it says the line whose equation is 3x minus 5y equals 4 is dilated by a scale factor of 5/3 centered at the origin. Which statement is correct? So this is the second dilation problem we've had in the last 4 problems. So definitely something you want to make sure and know how to do if you're planning on doing well on this test is dilations. All right? Our dilation. So let's look at some notes. When a line is dilated centered at the origin with any scale factor, 2 things are going to be true. 2 things. The slope of the image remains the same. Okay? The slope of the image remains the same. And the y-intercept is multiplied by the scale factor. All right, so hopefully you wrote those notes down. And as you look at our options here, all right, the only one, remember, we need to have the same slope. So we can eliminate 4 and 2, because 4 and 2, it talks about a different slope, and that's not going to be the case. And then number 3, it says has the same y-intercept. We know that's not going to be true because you're going to have to multiply the y-intercept by the scale factor. So our answer has to be 1. Okay, last one, number 15. It says which transformation would not carry a square onto itself? All right. So let's just draw. First of all, you need to start thinking about what are the properties of a square. All right. So that's one thing you should be thinking about. So I want you to think about that for a second. All right, so I want you to write down these couple of things about a square right here. It says the square has 4 equal congruent sides, 4 right angles. There are other properties of the square that will be important, but on this problem, I think that's just about what you need. So I'm going to draw a square over here. And remember, carry onto itself means that it would land directly on top of itself, okay? So, you know, we've talked about that in class, so hopefully you can get the picture of what that means. All the vertices would line up, all right? So let's think about that. A reflection over one of its diagonals. So let's just picture ourselves, or imagine drawing the diagonal of this square right there. If I draw that, if I reflect it, is it going to land right on top of itself? Is it going to be carried on top of itself? Well, this point over here is going to land over here, all right? This point is going to stay right where it's at, those 2 points. So that will definitely carry the square onto itself. Now, what if I did it the other way? Well, that's the same thing, all right? It'd be the same thing. It would definitely carry the square onto itself. So that's not going to be our answer, all right? So we'll go ahead and erase that. All right, and let's look at the second one. It says a rotation 90 degrees clockwise. Now, just a point I want to bring out. It says would not carry a square onto itself. So we're looking for the one that will not. That means 3 of them will. Okay, so keep that in mind. So rotation 90 degrees about its center. Well, 90 degrees, all the points. We've talked about that, 90 degrees, since each one of these angles is 90 degrees, each vertex would just move to the one next to it. Okay, that's all that would happen. So it would land on top of itself, all right? Let's see, it says 180 degree rotation about one of its vertices, all right? Now, let's just say do 180 degree about this. You've got a picture now. This point comes over here, right? And this point comes up here, something like that, all right? 180 degrees. The point is those vertices are not going to land on another vertex. Okay, so that is definitely not going to carry this square onto itself. Let's look at number 4 though, because number 4 is kind of interesting. All right, it says the perpendicular, a reflection over the perpendicular bisector of one side. Well, the perpendicular bisector would either be here, right? So if I reflected over that, that's going to land on itself, or it would be right here. Okay, so either way, it's going to land on top of itself. All right, so there we go. Those are questions 11 through 15 on the exam.